Good morning and welcome to Life Sciences Ontario's August Breakfast Series webinar. This morning we have a fun one, Summer of Science Family Edition. My name is Carolyn Lee. I am from the University of Waterloo with Cooperative and Experiential Education. I am very pleased to be hosting this morning and look forward to the science education programming that we'll be learning about today. Before I introduce our speakers, we would like to recognize the land we are standing on today is the traditional territory of many nations, including the Mississaugas of the Credit, the Anishinaabe, the Chippewa, the Haudenosaunee, and the Wendat peoples, and is now home to many diverse First Nations, Inuit, and Métis peoples. I also acknowledge that Ontario is covered by Treaty 13, signed with the Mississaugas of the Credit, and the Williams Treaties signed with multiple Mississaugas and Chippewa bands. For today, we have three speakers who will each present for about 15 minutes, followed by 5 minutes for questions. Please submit questions on the platform using the chat function at the bottom. So our first speaker today is Marie-Eve Naud. Marie-Eve is the Scientific Coordinator for Education and Outreach at the Institute for Research on Exoplanets, IREX, University of Montreal, and project manager for Discovering the Universe. Marie-Eve wants to participate in the development of the scientific culture of young people and the public in Quebec, so that Quebec positions itself as a leader to meet the major challenges of the decades to come. She believes this goal can be achieved by helping people to develop a greater sense of competence and empowering them with scientific knowledge through various opportunities to marvel at the universe, planet, nature, and humans. This can be accomplished through innovative practices in science education and communication, and by harnessing individual strengths through best practices in equity, inclusion, and diversity. She wants to participate in the development of the scientific culture of children, teenagers, and every Quebecer so that they position themselves as leaders in meeting the major challenges of the coming decades. She believes this can be achieved by helping people to develop a greater sense of competence and by allowing them to access scientific knowledge through diverse opportunities to marvel at the universe. She focuses on innovative and inclusive education and outreach initiatives that aim to reach everyone. So Marie-Eve's topic today is What Can You See in the August Night Sky? I'll hand it over to Marie-Eve.
Thanks a lot for this very thorough introduction. And in this introduction, you can, of course, switch Quebec to Canada. What I mean is that, like, locally, the people that I can touch, I hope that they can have a greater sense of marvel at the universe. So I'm really happy to talk to you today. And I'm talking to you from the Carina Nebula. It's an image that was recently taken by the Great James Webb Space Telescope that was launched in space past Christmas. And we just unraveled the first images of James Webb. So I'm happy to be here in this wonderful nebula where stars are born and stars die too. It's a bit far from here, but today with the magic of Zoom, I can be there. So I will share my screen and check that everything is all right. Yeah, so I'm extending my talk to what can you see in the summer night sky, and I hope to be able to talk to you about what you could observe like today, depending on where you are, but everywhere there are things to see. So as it was said in the introduction, I am an astrophysicist, which means that I really like the sky. I like space in general. My own specialty is exoplanets, and I'm still working for the Institute for Research on Exoplanets. And I just want to say a few words about this institute that is based in Quebec. We have a lot of world leaders in the field of exoplanet science, and we are also very involved in instrumentation. That is why we got a part in the Great James Webb Adventure. So in the next few weeks, months, years, you will hear a lot about the Space Telescope if it's not done yet. And we are really happy to be part of that and many other instrumental projects. You may know the Observatoire du Mont Mégantic, that we have in Quebec, but we also participate to instrumentation project all around the world, like in the biggest part of the world. And our education program is really, really strong, and I'm really proud to be part of it. We do initiatives for young children, for school children, for high school, for everybody actually, and we really, really like to share our passion for the sky with everyone. So yeah, I'm super happy to be here today. So what can you look in the sky? And I know that we've been a bit disconnected from the sky in the, I don't know, the past few decades, centuries, especially with the coming of the light that we have in the cities. There's a lot of light pollution for most of us. It's not, the connection with the sky was a bit affected by that. If I talk about myself, I live in Montreal. And of course, in Montreal, there's a lot of lights from everything, and it prevents us from seeing most of the stars. But I want to convince you today that even if you are not in a great setting, like countryside with full of stars, you can still appreciate the sky in the day and at night too. So the first thing you can look in the sky is the sun. And the sun is our very own star. It's a great star. It's my favorite star. And of course, I brought my my plushies. I don't know if it will show. Of course, our Earth goes around. It will be really hard with the background, but maybe, okay. I will go with my hands, it will be easier. Our sun and the Earth goes around the sun, of course. And that's why it's the brightest star that we see, and that we see it during the day. So there are many activities that you can do with the kids to notice, where is the sun, where does the sun set, how my shadow is affected all through the day. So I will give you a very precious resource a little later. I was introduced as also working for Discover the Universe. It's a very precious Canadian resource that we have. It gives some free resource to talk about astronomy with young and not that young. And they have activities, especially on the sun. And I'm showing you a picture of the sun setting. I mean, this is just the first show that the best show, I'd say, and it's free, and you can go anywhere and just watch the sunset, and just having these, just making these moment magic, I think is already a big thing. So the Plateau Astro is an initiative that a guy started here in Montreal, where he brings people on the Mont Royal, which is in the middle of Montreal, and he helps them appreciating the very free and awesome shows that are in the sky. So, oh, this is the activities I was talking to you about. So there are two activities that are related to the sun in the resource tab of the Discover the Universe website. And you can read that. It's easy to understand, and it's fun to do with the kids, like measuring their shadow all through the day, like with a chalk on the in the parking lot, for example, or doing a drawing of where the sun set all through the year. So these are fun and easy activities that you can do to just become more used to the movement of the sun in the sky. I want to introduce you to a very, very precious tool that is called Stellarium Web. It's a free tool, and I don't work for them, but I'm just using it a lot in my job as an astronomer. So I will try to go directly on Stellarium Web, and I already started a window. Can you confirm me that you still see my window now that I open Stellarium? Do you see Stellarium?
Yes, we can.
Okay, great.
Yeah.
So with Stellarium, what it does is that it reproduces the sky as it is at any moment from any location. So for example, here I chosen Toronto because I thought maybe some of you could be from Toronto, but it could be from anywhere really. And you can choose the time. And I chose 2 this afternoon because the next thing I want to have you notice is our very own natural satellite, or moon, the one that we call the moon. And you probably noticed that the moon can be seen at night, of course, and it's a common misconception that the moon can only be seen at night. You see that in the children books, they say that the sun is associated with the day. This is true for most of the planet, and they say that the moon is associated with night, but that's not always the case. You probably realize that the moon is often up. And for example, if we go at the time that is now, you'll see that the moon is visible. So if it's clear where you live, after that webinar, you could go and watch the moon, which just passed the third quarter. Of course, you won't see Jupiter and Venus because they're it's way too bright in the sky right now to see it. Yeah, so it's really fun to look at the moon at many different times and to notice what can be how it evolves over time. And so we just passed third quarter. The moon, I had my plush, but yeah, the moon is going around the Earth, and depending on where it is around the Earth, it will show a different face. So it's a common misconception also that it's the clouds that affect the shape of the moon or anything like that. But no, the moon is always a big round sphere, and it depends on what part we see, what part is lit in by the sun, and that's what explains the face. And you can find in many different sites or your calendar, your good old calendar, what phases of the moon it is right now. So we just passed third quarter, as I said, and we're going through new moon. So when it's new moon, you don't see the moon, but just before that, you'll see very nice crescents, and this is a very fun to watch in the sky. And I wanted to show you especially two other time that could be nice to look at the moon, and it's when you will have earth shine. So you might have noticed that in some occasions you can see the crescent of the moon, but you can also see the rest of the moon that is a bit less bright. What is it? That's the Earth. It's the fact that the sun shines at the moon and we can see that light directly, but the sun also shines at the Earth. And this light is reflected on the moon and back to us. So when you look at the moon and at some specific time, and I identified one such time for you on July 30, just at night, where before you go to bed, maybe, or just when you start your fire, or I don't know, whatever you do during the summer at night, you will be able to see the earth shine, and you will also be able to see it 1 month later at the end of August. And this is very fun, to imagine that the earth is shining through the moon. My master thesis project was actually about that. We were studying the earth shine to know more about what an habitable and inhabited planet would look like from afar, and we were using the earth shine to figure it out. It's a bit complicated, but it's like if it was allowing us to see it as if it was really, really distant. So a very fun observation to make, the earth shine. If you want to learn more about the phases of the moon, again, I refer you to the resource tab of the Discover the Universe. There are 3, I think, activities related to the moon. The Moon Observation Journal is one of my favorite. It's so simple, but it's really great with the kids, maybe every week during a month or a couple of days during the month, you go out and you try to identify the moon. You can use Stellarium for that. You try to spot the moon, I mean, and you just draw what you see, and the kids will develop a very good relationship with the moon that way. There are specific activities for evening moon and daytime moon, and you can learn more about when to see the moon during the day and at night. So if we go to the sky at night, I'm still in Stellarium. And now I am tonight around 9:30. It depends on where you live, of course. And the first thing that I was personally able to spot in the sky last night and many other nights that I do observation is those 3 stars that are super bright. So if you are in a city, your sky will look like that even when it's the middle of the night. actually, because now Stellarium shows you the sky in a pristine sky. So when it's getting dark, you have less star, of course, but when it's super dark, you have a lot of stars that are shown in Stellarium. So it's more close to what you will find in the countryside. But if you are in the city, you will see those 3 stars like clearly at night. And those 3 stars, it's not a constellation per se, maybe you know the word constellation, but it's an asterism. It means that it's a configuration of stars in the sky that we identify and that we know. So these 3 stars are very bright stars, Vega, Altair, and Deneb. They are part of 3 different constellations, and it can help you identify constellations because they are the easiest to spot, I'd say. So for this little story, why these stars are bright, Vega and Altair are quite big stars, but they are close to us. And when I say close, I mean like tens of light years, so it's still very, very far. But Deneb is much farther out, like 1,000 and something light years, but it's a giant star, so it also shows very bright in the sky. And as I said, maybe you can still spot, like in the Stellarium, you can make appear, like, I know we don't see it very well, but in the bottom of the screen, you can add the constellation lines and the constellation drawings. So you can see that I made appear the constellations here, the Cygnus constellation, the Lyra constellation, the Aquila constellation. They are the ones that host those 3 stars, and you can identify the Cygnus constellation quite well using the summer triangle. Then another constellation that I would invite you to see, and maybe just to say that it allow me to tell you that constellations are not places that we can go to. Sometimes children think that we can go to the constellation of the Great Bear. I even saw that in a children's book sometimes, but they are not actual places. They are just drawings that we imagine in the sky, and the stars that make a constellation can be very far apart, like from us. It's just that they align in the sky for us, but one can be very farther out. So yeah, the Cassiopeia is another constellation that I would invite you to try and find. So we are still tonight, a bit later, and you can see here the Deneb star. So you can maybe find the Cassiopeia star that looks like a W shape at this time of the year. And during the winter, it looks like an M shape. And there's a story with that, very cute story about, maybe not that cute, but I mean, it implies a queen that was too self-centered and love is her image. And it was forced to adopt this non-gracious posture in the sky, and he upside down, and well, you can look at it, but there are always great stories related to constellations. Another constellation, of course, like we were in Cassiopeia, and this is probably the one that most of us recognize. This is what it looks in a pristine sky, but from Montreal, I can assure you that if we are able to see all these, like the famous pot, it's already good. And finally, maybe one that is a bit harder, you can try and spot the Scorpius. That looks like you can see this star, this star, this star, and this star will show even in a polluted sky. And maybe to spot it more easily, I can tell you another time that you should maybe go out and watch the sky. It's on the 6th of August, where the moon will be in the Scorpius constellation, so around 10 at night, and you will be able to spot a very bright star in that constellation that is called Antares. Then the planets, you can see planets of our own solar system with the naked eye. The planets are not that easy to spot these days. Most of them are seen in the morning sky. So in the morning sky at around 5:30, you'll be able to see Jupiter. This is on August 15. And I just want to tell you also that around August 14, it's the moment of the year where it's moment of the cycle where it's better to watch at Saturn because it's in opposition. So it's a great time to watch it as well. This is in the night sky, but it's low on the horizon, but it's still a good time to see Saturn. You won't be able to distinguish it from the other stars. So like the stellarium that I'm showing you from a web browser, you can also download it to your phone. It's a small cost, but there are similar applications that you can download for free. And you can actually check in the sky, oh, that bright spot is Saturn, because you can adjust and watch with your phone what it is. And maybe one last thing that I would like to invite you to see, even though it's not that good of a year this year, is the meteor shower called the Perseids. This is, I think, the favorite meteor shower of the year because it's during the summer and it's warm. So you can, it's when the Earth goes around the sun, sometimes it crosses the path of places where there was a comet. And a comet leaves a lot of stuff behind, basically like ice and rocks. And when the Earth goes through that, there will be a lot of shooting stars. So shooting stars are just basically little rocks and stuff that get in the atmosphere, and they are bright because when they get in. So this is a great time to watch the Perseid around August 12, 13. It's not a great year because this year the moon is in a phase where it's really bright. So it will be less easy to see, but you would still be able to see Perseids. So with that, I invite you to look at the sky. I hope you will make some fabulous observations during the summer. And yes, thanks for listening.
Thank you so much, Marie-Eve. I love this website. I didn't know about this, so I'm going to be definitely sharing it with my kids. I actually have a couple of questions, and I'm glad you touched on the planets because I think it was a few years ago, my family, we go camping a lot, and it was August, and we had a really great view of, we thought it was Venus. And I guess maybe every summer it just depends. It'll be a little different, I guess, what you can see. But I remember it was very bright in the sky, and I can't remember how we figured out. I think maybe we were just Googling what planets can you see in the sky right now in Ontario.
Yes, Venus is a very, very bright object in the night sky. It's unfortunate because this year it's not that good of a year, but I remember, I think it was in 2020 or 2029, it was very, very bright in the night sky. So it really depends, because I chose any year now, but depending on the position of the planets around their orbit, you will see them sometimes, and sometimes you won't see them. So you really need an app to figure out. Even I need an app because I don't have that pattern in my head at all time. But yes, and Venus is a precious view because it's such a bright star. You'd be surprised at the amount of phone calls we get for OVNI, and they're like, oh my gosh, we've seen something strange. And in the end, it's just planet Venus. And our ancestors were super used to see that planet, and they developed a very strong connection with that planet because it's a very, very bright object in the sky.
That's great. I have one other question, and I don't know if this is necessarily I also, when I remember when I was a kid, seeing the Northern Lights or Aurora Borealis, and in Calgary, and also actually just in like central Ontario even. I'm not really hearing much, or it doesn't seem to be coming up. I know last year there was, I think it was in Ontario, that there might have been a chance to see them, but it was, I think, overcast. Is that something that is less likely to happen now, further south? Or is that something that it's just it could randomly happen for us again?
The Northern Lights, the phenomenon is, it is due to the fact that there are charged particles that come from the sun at all time, basically, but sometimes there are more. So depending on where the sun is in its cycle, sometimes there will be a lot of particles emitted and sometimes there will be less. And the other part that we need to get the Northern Lights is the strong magnetic field of our planet. And I'm holding my plush toy here, but the magnetic field of our planet, it does a shape like that. And how I can say it's almost like a path for the charged particle to follow. So naturally, because of the fact that the particles are charged electrically and that there is a magnetic field, these particles will follow the lines and get into the atmosphere of our planet much more at the pole where the magnetic field does that. If it's a period where there's a lot of charged particles, you can see them a bit further south. But basically, the Northern Lights are a show that is a very common sighting for people in the north. If there are some people listening from the Northern Territories, for example, you can see that quite often. But when we are in the south, like me in Montreal, I never see Northern Lights. So if you are up north and you happen to be in a great period, there are websites, I don't know at them at the top of my head, but there are websites that will give you warnings when it's a great period to observe the Northern Lights that are apparently something very beautiful that I never see myself, unfortunately.
Great, thank you. I hope it does happen. Like I said, I've seen them twice and it was fantastic. So thank you so much, Marie-Eve. That was fantastic. That resource stellarium, I think that's great. And I'm going to be using that myself.
Yes. And maybe just one last thing that
sure.
I would like to mention. On April 8th, 2024, there will be a total solar eclipse in many places in Canada. So you should really put that in your calendar and get the glasses you need for everyone you love. They are super cheap and it's a very, very, very special event that happens rarely in a given point. So April 8th, 2024.
All right, April 8th, 2024. Thank you so much.
My pleasure.
Yes. All right, so on to our second speaker today. This will be Let's Talk Science with Diana Shumeyko and Shelby Law. Diana is going into her third year at McGill University, where she is majoring in computer science. When she finishes her degree, she hopes to pursue a career in cybersecurity or business consulting. And Shelby is a queer, non-binary educator-to-be, using the pronouns they and them. After completing their undergrad in wildlife conservation and biology at the University of Guelph, Shelby studied the interaction between plants and mycorrhizal fungi as part of their Master of Science in Ecology. Their background in visual arts obtained prior to delving into the STEM world is leading them to become a biology and visual arts teacher. So today they will be working on a solution for temperature control by using household items to create containers that can keep an ice cube frozen. So with that, I'll pass it over to Diana and Shelby.
Perfect. Thank you so much for the introduction. So today, as mentioned, we're going to be doing a temperature control challenge. So a little more about us. Do you want to go to the next slide? As mentioned, I study at McGill University. I'm part of the chess club there. I'm also going to study abroad next year to England for a whole year. I also am doing a hackathon, and that is my pet fish, Maurice, who I love very much.
She's been keeping you really good company as we work from home and do school from home. And as was mentioned, my name's Shelby and my pronouns are they, them. I'm calling from Guelph right now, which is on the traditional territory and treaty lands of Mississauga of the Credit. And prior to getting into the STEM world, I was doing schooling in fine arts. So I was really into art, which I still am now. And then when I was in my undergrad degree at the University of Guelph doing wildlife conservation, I got really into plants, which is that picture up at the top right there is actually inside of plant roots that we stained so we could see all the different parts. And seeing those things got me really, really interested in plants. Before that, I thought that animals were the thing that I was loving, which makes sense. We get to see them a lot more. They're running around, they're doing things, they're exciting. But I realized that plants and fungi are really exciting and decided to do my master's in that, which these photographs at the bottom here are all showing the progress that I did in that. And these purple blobs here that don't really look like much are actually the fungi that I study. So this is a close-up picture, really, really close through a microscope. And these are parts of the fungi that live inside those plant roots. So they live together in what's called a mutualism. So they take care of each other, which I think is pretty cool. But back to what we're doing today. So we're not talking about plants, we're not talking about computer science, we're talking about temperature. So temperature is a measure of energy. When it's really cold, this means that the atoms that are all around us have low energy, so they're not moving around very much. When things are really, really hot, like, I don't know about you, but I've been in a heat wave, so it's been really, really hot where I am. That's when the atoms around us are in high energy mode. There's a lot of movement. The world's very hot, at least for me where I am. And temperature control refers to controlling temperature, keeping it where we want it. So just say something's cold, we want to keep it cold. So we want to keep the atoms from getting worked up and moving around and the world getting hot. Whereas if we want to keep something hot, we want to keep those atoms from escaping their heat and going into maybe a cooler area. So in terms of temperature, atoms always like to move from hot to cold. And so when just say right now, if you have air conditioning inside and you open your door, you're letting that heat in. Sometimes we say the cold escapes, but it's really letting the heat in and the cold just dissipates out. So I just talked about one example of our houses wanting to be cold in the summer. If you have air conditioning, which I don't even have, so it's just warm. That's something that we try to keep cold in the summer and hot in the winter here in Canada. Using the Q&A, I'd like to hear from everyone who's on our call today. What are some other things you can think of that we keep cold or that we keep hot? And why do we do that? So like with our houses, we want to keep them cold in the summer because it's uncomfortable to be too hot. And in the winter, we would just freeze if we were outside. So we need to be in that comfortable range. What are some other things that you can think of? Oh yeah, I have an answer here, like food, to keep it fresh. That's a good example. We often need to keep food cold in our fridge to keep it fresh, or we might need to keep it hot. I don't see anything else coming in. Diana, can you think of anything else?
I'm gonna say vaccines.
Oh, yeah, that's a great one. We need to keep our vaccines cold. It's really, really relevant. Yeah, that was something that's been really important the last couple of years. How about how? So when I talked about keeping a house cold, we used air conditioning. That's one way we can do it. And in the winter, we use our heat, which might be burning fossil fuels inside our house, so burning gas. It might be from electricity if we have space heaters, or we might even be lucky enough to have a fireplace in our home where we burn wood. So those are all ways that we keep it cold in the summer, hot in the winter. How about food? Let's think, what do we do to keep our food hot and cold? So I mentioned earlier refrigerators, and if we want to keep something hot, we might leave it on the stove, or we might have a slow cooker that keeps it hot. Yeah, I see in the chat we have an answer here for food. Cook, boil, and oven. Yeah, these are all ways that we get our food hot, and we might be able to keep it that way. I know that if I need to keep something hot that I've cooked on the stove, I might put it in the oven. If I'm making a lot of pancakes for the family. But what if we don't have electricity? So I don't know if any of you have experienced really long blackouts, but I remember when I was a kid, there was a week-long blackout and it was so hot. Maybe it wasn't a week long, but that's what I remember it being because it was just very uncomfortable. We did get to eat all of the ice cream inside of my freezer, which was great though. But we had to come up with solutions to keep things cold during that time, which is what we're going to work on today. So let Diana introduce our challenge for today.
Yeah, so the challenge today is you're going to be building your very own cooler that's going to keep an ice cube frozen for longer than room temperature. So what you're going to be using is anything you can find that is recyclable, reusable in your house. Some of the suggested materials we have is aluminum, cardboard. You're definitely going to be needing probably tape, newspaper, maybe cotton balls. Think about some of the things that are good insulators. That's going to be really helpful. So we're going to give you 10 minutes to build your little cooler. And after those 10 minutes, you're going to go to your freezer and take 2 ice cubes out. You're going to place 1 ice cube inside your cooler and 1 ice cube outside, just on a plate or a container. And when that ice cube outside's all melted, you're going to check inside your cooler. And if your ice cube in the cooler is all good, you succeeded. You did a great job. So we'll start the 10 minutes now. Get your materials, start building. We'll let you know when you have 5 minutes to go and when you're all done. So we're also going to build our coolers alongside with you. We have a little challenge going on.
Yes, our little challenge between us. So I already started cutting my cardboard, so I might have cheated there. And also feel free to use the Q&A if you want to tell us what materials you're using along the way, if you have any questions about the materials and what they do. What are you using for yours, Diana?
I have a peach can, some aluminum, some cardboard. I might have to go get scissors and tape. What about you?
I'm just using cardboard, paper that I got that I've been saving from inside of deliveries because my house gets a lot of them, and possibly aluminum foil. I'm not sure. I might just use it to seal up so that if there is any water leaking, I don't get all my cardboard wet. But I tried to look for a can or something plastic, but my recycling just went out. So I didn't have any of that.
I'll send some cans from Montreal.
Maybe while people are working on their ice box, we could maybe address some questions now, because it might be a bit tight for time by the time we're done the activity. I just had a question for both of you, Diana and Shelby, working for Let's Talk Science, if you can do this while doing the activity. Do you normally go into schools? Is that usually where you would be doing these sorts of workshops? I know virtually it's a bit of a challenge sometimes, but is it normally schools, and what other sort of scenarios do you present these sorts of workshops?
Yeah, before COVID, it was a lot of being in schools. Prior to working for Let's Talk Science, I volunteered for 1.5 years, but that was right as the pandemic started hitting. So I've never actually been in a classroom, sadly. So usually, yeah, we would go in and do activities hands-on, really get to interact with everybody. But now we mostly do, mostly do virtual things. Some of our team members have got to go into summer camps, which is what we end up doing in the summer, going to summer camps or community groups. So not just teachers can come call us up, but anyone who's doing any kind of educating with you.
Well, that's great. And I know this is not necessarily the field that either of you are in, but do you guys actually do workshops in your areas of expertise, say plants or maybe more computer type workshops? Do you do those as well?
Yeah, so we go through all areas of science. I know on our website, there's every category. Shelby and I have been developing new activities that are personally related to our fields, which should be coming soon. We're very excited about that. But it's definitely interesting working with different areas as well, because I know I'm learning much more about biology now and kind of stepping away from computer science, which I've been enjoying a lot.
That's great. Thank you. I'm not going to distract you from what you're doing. I thought I would just maybe squeeze a couple questions in there.
Oh, absolutely. And if anyone thinks of any in the audience and you want to pop it in the Q&A, we can always answer it while we're over here. I'm just doing a lot of taping and having that struggle where you get the tape stuck to the roll and you can't find the end. I have part one of mine done, which is the box the ice cube is going to sit in. Just made a little cardboard box. The tinfoil is just there to keep the cardboard dry. Could have also used like a plastic bag to put it in. If this was going out in the sunlight, I would have put tinfoil all the way on the outside to reflect the sun off of it. But since it's just in my house, I think it'll be fine just being cardboard.
So you guys all have 4 more minutes, and then we're going to move on to our closing remarks and to our next speaker. I'll give you all 1 more minute to finish up, and then we are going to move on.
I'm done with seconds to spare.
Perfect. Well then, time's up for everyone. I hope you liked the activity. And you guys can go get your ice cubes if you would like, or wait until after the live stream's over to begin.
Yeah, and if you want to show us your finished project, we'd love to hear what materials you used, what it looks like. You could even send us a picture and share it with us on social media. So you can follow us on Twitter, find us on Facebook at Let's Talk Science, and hashtag Let's Talk Science so we can find it. And thank you all for having us here today.
Thank you so much, Shelby and Diana. It's very cool, and it's a good reminder that there's some really fun science projects we can do that don't even really take a lot of time and are really interesting for kids to do. So thank you so much. And yes, if anyone has any questions, pop them in the Q&A, and we can even answer them on the fly as we move on to the next presenter. So our final speakers today are the STEAM sisters, Swapna and Sandhya Mila Bathula. Apologies if I didn't pronounce your name correctly. They love sharing their passion for STEAM, so science, technology, engineering, art, and math, and bringing their adventures to you. They believe STEAM is for everyone, and it is their mission to encourage youth to discover the magic and excitement for themselves in engaging and accessible ways. So join them as they go full steam ahead through hands-on activities, digital and broadcast media, and at an event near you. So many thanks for your support. It helps them to complete these projects and embark on bigger and more exciting projects to share with you. So their topic today is reaction time. Why is it important, and how can you improve it? And so with that, I'll pass it over.
Thank you so much. We're just going to get our slides up here. All right, I think you'll be able to see that in a second. Perfect. Well, hello, everyone. We are the STEAM Sisters. My name is Sandhya.
My name is Swapna.
And we are so excited to be here with you today. We are both science communicators, as was just mentioned very kindly. We're also outreach coordinators and educators, hosts on television and digital media shows, podcasters, and also students at the University of Toronto, where we study concussions. We're going to be talking about reaction time today, but we're going to start with a bit of a primer on concussions and how reaction time can be affected.
So we didn't actually have a chance to eat yet, though, so we think it's a good moment for a little bit of brain food, literally. Not for real. This is a Jell-O brain that we made, and it smells amazing because it's made of strawberry Jell-O. We usually just have one of those in the freezer as concussion researchers. Just kidding. But while this isn't a real brain, it can tell us a lot because our brains are actually a similar consistency to Jell-O. So they're wiggly and soft and delicate, and that's a good reason for us to want to take extra care of them because we can't function without them the way that we do. We need to take extra special care of this one because it's got a bit of brain freeze.
All right. So we're going to talk about concussions briefly. I think we can use the chat here. So has anyone here ever had a concussion? If you can't use the chat, maybe put that in the Q&A if it's a yes, no. If you can't respond, that's okay as well. We can just get to the next part here.
So you can answer that question in the chat as we continue. Have you ever had a concussion, or do you know anyone who has had one? But in the meantime, what is a concussion anyway? Well, it's an injury to the brain, and it's a pretty big health problem in society. There are more than 200,000 concussions each year in Canada, and it's also the most common brain injury and a pretty serious one that you should take care of immediately if it ever happens, because unfortunately, although it usually will get better over time, it does have the potential to have lasting effects, especially if we don't take care of it. So these effects can be physiological, so things that we can physically feel in our bodies, or psychological, and those are things that we feel in terms of our mood or emotions. It can also have effects that can affect our interactions with our families, friends, and others around us. So it's an important topic for sure.
So what's even in our brains? Well, we know that our brains are super important to help us do all the things that we do every day, moving, thinking, eating, sleeping, homework, work, playing, all sorts of things.
So inside our brains, we have different kinds of cells. One of the most important are neurons, which send signals to each other and to the rest of the body. There are about 100 billion neurons. There's some sound effects in the background for that one. There are 100 billion neurons in our brains, and axons are a part of the brain cell that helps with sending and receiving signals.
There are other supporting cells, and on a larger level, there are different lobes or parts in our brains that are responsible for specific functions like memory, vision, smell, and so on.
So the GIF that you see here is a great example of how a concussion in sport could happen. You can clearly,
terrible example.
or a terrible example. You can clearly see how this poor guy's face changes shape when he's hit, and just imagine how much his brain is moving around inside his skull. But because inside his skull, it's a pretty invisible injury, unlike the more obvious ones like a broken bone that you can see quite clearly.
Exactly. So now let's do a quick Kahoot to test what we know about concussions or to learn more before we get into reaction time specifically. So please go to kahoot.it on a different tab or a different device if you have one, and put in this game code that you're going to see momentarily. So the game code is 772
And
5923.
so you're going to be going to kahoot.it, that is you see right here, on another tab on the same device that you're on, or on another device if you have a phone or another device around.
And so, oh, we've got Witty Hen joining us. We'll wait for a few people to join. You can continue to join as we get started as well. But we're just going to get a few people to join here.
Thank you for joining us, Woody Hen.
Indeed, the game pin again is right here on the screen. Snowy Puffin,
Gentle Gecko.
Maybe we'll just wait for a few more before we get started. And you'll see the questions appear on the screen that we're showing to you, and you'll be able to respond on your screen. Okay, for time's sake, we'll get started, but as I said, people can continue to
Join us
as
at
rational
any
mind.
point. Okay.
All right, we've just got, I think, 5 questions on this, and then we'll jump right into the reaction time. True or false? Helmets do not prevent concussions. Is that true or false? Make sure to get your answers in. We've got 4 seconds left. True. Helmets do not necessarily prevent concussions.
Although that can change in the near future because more and more research is showing that there are possibilities for types of helmets that could potentially at least reduce the severity. Okay. Next up, Snowy Puffin, way to go in the lead there. Number 2, true or false, a hit to the head is required for a concussion to happen.
Is that true or false? All right, so that was false.
Great job.
Can have a hit to the body as well.
I think we have some concussion experts in the crowd here.
Perfect. Concussed people can experience symptoms of depression. Is that true or false?
Such a sad brain.
Excellent job, everybody.
Well done.
Yes, indeed, this is true.
Okay, oh, we have people on fire here. Penultimate question, second to last, where do concussions happen? In sport, at home, on the road, or all of the above? Couple seconds left.
All of the above, that's correct. They can happen anywhere.
You're acing this. Okay, last one.
All right. Which is not a symptom of concussion? Dizziness, sensitivity to light, concentration problems, or diarrhea.
These are all problems, but one of them is not related to concussions.
That's right.
You
Most of you got
spotted
it. Diarrhea is not a symptom of concussion.
Good
All right,
stuff.
great job, everybody. We'll just quickly see who's on the podium here before we move to the next part. Rational line, great job.
Great rational job.
Snowy Puffin and
At the top of our leaderboard.
Witty Hen.
Witty Hen.
Congratulations, everybody. I hope you all learned something there. All right, we're going to move back to our slides.
Yes, we are. One moment. I think you can see our slides again, which is perfect because next up is this one. So as we saw with the boxers, the boxer in that GIF there, someone can get a concussion if they receive a hit to the head, but that's not the only way. As you all identified, you can get a concussion from a blow to your body too, because that can have enough impact to make your brain move too much in your skull. And this can result in damage on the level of the cells in your brain, which you then feel as symptoms. But usually this injury heals over a period of time. However, some people will have longer lasting effects.
And we saw all the different ways, potential ways that you can get concussion through the Kahoot. So for example, sport, car accidents, falls, accidents at home, school, or work, even including something like banging your head on a cupboard.
So symptoms are things that you feel, and signs are things that someone else can see. So what are some signs and symptoms of a concussion? They are physiological, cognitive, and psychological signs and symptoms. Physiological ones are how your body works and feels. Cognitive ones have to do with things like learning and memory. And psychological ones are related to how you feel, like your emotion and mood.
So another way that concussions can affect you is by making it harder for you to react to something, like a ball being thrown in your direction. And this means that your reaction time is longer. But what is reaction time? We're going to find out briefly with this quick video. We'll share sound.
Hi, we're the Steve Sisters. I'm Sandhya.
And I'm Swapna.
We love exploring
Science,
technology,
engineering,
art.
and math.
Have you ever wondered how quick you are? Well, today we're gonna find out because we're gonna be testing our reaction time.
But what exactly is reaction time?
It's a good question. Well, it's basically how quickly we respond to a stimulus, which is something that changes in the environment.
Like this?
Exactly, so now let's check out those reaction times.
And all we'll need to do this are a ruler and a family member. So let's try this out.
So what we're gonna do first is put this ruler just by your fingers
Okay.
at the 0 centimeter mark, but you're not touching it.
Nope.
The catch here is I'm not gonna tell you when I drop it, you're relying on your reaction time alone. Nice.
Nice!
You got?
7 centimeters.
Cool.
Let's try it on you too.
Okay. I got 7 centimeters.
We really are twins.
So how do you convert the centimeters from the ruler to seconds?
Well, we have a formula for that, and that is the time of your reaction is equal to the square root of 2 times the distance in meters over the acceleration of gravity, which is 9.8 meters per second squared. You can do that calculation, but we've also done it and made this chart. So you can see your distance in centimeters straight off the ruler and your corresponding reaction time in seconds. So we both got 7 centimeters. So our reaction time was 0.120 seconds. And here's the rest of that chart.
So what's actually going on here? Well, when your eyes start to see that ruler drop, it sends a signal to your brain, which then reacts and sends a signal to your hand.
So your reaction time is just the time that it takes from when you take in that information and the ruler starts to drop to when you catch it. So do you want your reaction time to be even faster? Well, don't rule yourself out. All it takes is practice.
Exactly, so try this at home and challenge your whole family.
Hope you enjoyed this video.
Make sure to check out the Shasbury Kids YouTube channel for tons of videos and full episodes of TV shows streaming for free.
So that's a little bit about reaction time in itself and how to do that little activity with all you need is a ruler and another person.
And so now we all know what reaction time is and how we can test it. When you have a concussion, though, your reaction time can be affected. And it can be harder to concentrate and it can be harder to react. So it might take longer to react to things. So we will demonstrate that by doing the reaction time test live here for you. But Instead of just doing it the way we did in that video, I'm going to be reciting the alphabet backwards to make it hard for me to concentrate on catching the ruler.
And that is to replicate having some difficulty with concentration.
Like it would be if someone had a concussion.
Are you ready?
You can recite the alphabet backwards with me. I think I'm ready.
And if you have a ruler at home, you can try this out with us.
We will, should we stop sharing so that you can see?
Yes, let's do that.
Here, we'll stop sharing so you can see how well or bad I do. Alphabet backwards, yes, I think I've got
So you'll
it.
be putting your fingers right by the 1 centimeter there.
Okay, so it's right by the
So I'll see
1
it.
centimeter.
All right. I'll drop the ruler at some point.
So I had 7 centimeters when I wasn't reciting the alphabet backwards. Z, Y, X, W, V, U, T. What did you get? 14 centimeters, double my time, double my reaction time from when I wasn't, I guess, distracted.
All right, so that's a good demonstration of the difference if you have a concussion or are distracted in some way. But let's go back to our slides.
And so as we're pulling up the slides, we invite you to try that yourself and try that both ways, with the distraction and without the distraction.
And see what the difference is for you. All right, I think we've got one last quick activity we're going to show you here.
Oh, I think perhaps we might just cut our camera for the time being though, because our connection's going a little wonky.
So maybe let's copy our link over for that activity.
Okay.
Hi, we're the Steam Sisters.
We've seen that one already.
All right, so for this next activity here, if you don't have a ruler, don't worry. There are many more ways to test your reaction time, and so you don't end up in a situation like this poor person here on the slide. So we're going to just share with you a link to put in the chat for another reaction time test. This one is all about baseball, and this online tool will get you to click when you see the baseball to hit it. It tests if you can react fast enough to hit the fastball, and let's take a minute to try it out together.
Okay.
So we're just getting this link for you. I think there's this like connection shit. All right, we're going to be throwing this in the chat, I think.
Chat's opening for us, taking just a moment. Get your batter up skills in place. I think you can see the link here.
So I think we are a little bit over time here. So
we're
we
just
will
gonna-
tell you what this is going to do, and you can try this at home.
Okay, so we put the link in the chat if you want to try it for yourselves. When you go to the website, you navigate it like this. There's a little circle here that says play ball. I'm going to click on it, and then it's going to test my reaction time, how quickly I can get. Oh, that was a swing and a miss. To try one more time.
Batter up.
Okay. We will
What our previous tries were like.
go back to our slides. So you can practice as you see that we did. We had some good tries and some not so great tries, but all it takes is practice, and you can improve your reaction time. And with that,
Great. Thank you so much to the STEAM sisters. I think there might be a little bit of a connectivity issue with your signal, but thank you so much. And I think, I'm not sure if the link was shared to everyone, but we will make sure that we get it out to everyone who attended today. We're a bit over time right now. So I'm just going to hand it over to Andy Donovan for some closing remarks. Thank you to everyone who's attended today.
Thanks so much, Carolyn, and thank you to today's speakers, Mary-Eve, Diana, Shelby, and of course the STEAM sisters. We truly appreciate your participation in today's event. And of course, special thanks to our host, moderator, and longtime LSO volunteer, Carolyn Lee of Waterloo University. And we truly thank all of our attendees for joining us today. Before we let you go, we wanted to share a few upcoming events and deadlines. On August 10th, we'll be hosting our annual golf tournament, which is officially sold out. However, there are a few sponsorship opportunities still available, so please reach out to any one of us. Our annual LSO road trip, which touches down in various markets around the province where life sciences is alive and well, takes place during Global Biotech Week, which is September 26th to the 30th. And so far, we have lined up Windsor for Monday and Brampton for Tuesday, and watch out for additional markets as we get closer to the date. Each year, we publish LSO success stories, which we share with provincial MPPs in the fall, where we highlight member and non-member life sciences companies. The deadline to submit is September 6th, and if you are a life sciences company and would like to be included in this annual publication, please feel free to reach out to us. Finally, nominations for our annual awards presentation are open. If you know of individuals and companies within life sciences, please nominate them for the 2023 awards event. Deadline is October 3rd. Now, we'd like to thank our sponsors, our platinum sponsors shown here, our gold sponsors, and of course, our silver sponsors. And with that, we'd like to thank you all for attending and wish you a great day.